Welcome to Bürkert Bytes. My name is Chris Hoey. Digitisation is drastically transforming the automation world, as well as creating a lot of opportunity. In this series of videos, we take you through the best practice for digital connectivity in process automation. We hope you enjoy. Welcome to our digital connectivity video on Ethernet IP. Ethernet IP is also a widely used network protocol, and these days more and more it's being taken to the field. When it's taken to the field, we tend to use devices like that are capable of running a device level ring, or a DLR, which is a redundant protocol which can hook up to multiple devices out in the field. So with a device level ring, you loop in and out of each device, and you come back and you close that ring at the other end. What it gives you the ability to do is have a break in the network, which I'll simulate here by disconnecting the unit, and everything stays green and everything stays operational. And of course, it is reported as an error, so that in that if you're alerted of that break, and you can go and repair it. And of plugging it back in again, it immediately corrects itself and goes back to full run mode. So in this ring, and with Ethernet in the field, there's three different ways that we can connect to devices in the field. And that is via direct connection, which we've demonstrated here by connecting this modulating butterfly valve directly to the Ethernet IP. Alternatively, we can go through I/O blocks. We have a couple of examples here. One is a pneumatic block manifold, and the other one is the integration that Bürkert has with Rockwell and their point I/O system. This integration is around 15 years old, and it's still quite current. What it gives you is the capability to have a complete I/O cluster in our in a remote field situation. In other words, not just having a valve bank where you can have some pneumatic outputs, but by actually having a mixture of analogs, digitals, maybe some high-speed counters, temperature sensors, whatever you wish, as well as valve outputs as well. And they can all sit in a simple cluster that can be put into the field. Just like other systems, you'll notice that the Rockwell system is a Hotswap capable. In other words, you can pull out the electronics and you do get an alert. And of course, by replacing the electronics, it will automatically heal and go back into full run mode. We've done exactly the same with the Bürkert valves. We have the option of having a full hot swap capability to swap out valves under full operational, so full air and full electrical connection. And of course, you can replace the valve and get back up and running in a very quick period of time. We do this as Bürkert is designed to run in a process automation industry. And in process automation, you have things like fermenters and distillation, etc. You can't turn those processes off. So the third way to connect with the network in the field is to go via a gateway. And there are several examples of this. Of course, using this gateway example here is using the Bürkert EDIP platform, or of course you could use IO-Link or ASCII-Bus, any of those as well, which we will demonstrate in other videos. Just to give you an example here of the EDIP platform, we have our modulating control valve EVA, which is operating in the field there. We can come straight to that device here, and we can type in a set point, let's just say 50%, and hit enter, and you'll see the valve will operate directly to 50%, and our feedback says it's exactly at 50%, which you can also see on the trend here on the display. If I put that back now to 25%, you'll see that move straight back down to 25. I'm going to hand over now to Nelson, who's going to take you through the integration of the Rockwell Point I/O system with the Bürkert 8644 and how it gets brought into the PLC system.
Thanks, Chris. We're going to have a look at the Bürkert 8644 and how that's integrated into Rockwell Studio 5000. Now we've got Studio 5000 loaded here, and we can see that we've created a project with our Ethernet network, and we've imported the .io modules into a slot chassis, 7-slot chassis. The first module, being the interface module, is an AENT-R dual port Ethernet. We've simply given that an IP address and a name. We've then got 4 other modules, which are Rockwell modules, sitting on the rack. And then what we've created is a 1734 generic module for our 8644 valve manifold. And depending on the size of the manifold, we put a certain assembly instance number for the input, output, and configuration. Once these are set correctly and downloaded into the program, we can then go and monitor the tags. The output module in this case is on output 5, and if we dig deep into the tags, we can actually modify these outputs as required. So to test a valve, I'm going to put a value of 1 in, and it will energize my valve. To turn the valve off, put a value of 0. Back to you, Chris.
Thanks, Nelson. Ethernet IP is used in a wide range of industries, from heavy industrial mining right through to food and beverage and others. And you'll see that Bürkert has a range of products that go throughout all of those applications, which include the I/O blocks, valves for on-off modulating, mass flow meters, mass flow controllers, electric modulating valves, and of course our gateways available for this, as well as ASSI and IO-Link. So there's many ways to connect to it. And there you have it, an overview of Ethernet IP capabilities. I hope you enjoyed this Bürkert Byte video. There's a number in the series. I hope you take the opportunity to watch them all. And if you do have an application, our local engineering team is here to support you. Thanks.